Hello, this video is going to show how we can measure code coverage on assembler code. And what I want to be able to do is to execute some assembler code, and as it executes I want to find out which lines of code have we executed, and more importantly which lines have we not executed. Now I'm going to be using the ARM7 assembler in order to be able to show this. But as we can see here, I've got several other assembler test beds installed for NEOS 2, PowerPC, TMS320, DSPIC33, and also Intel ATX86, and we have many more assembler test beds, but the one I'm going to be using here is the ARM7 test bed. So I need some ARM code, and what I have connected to my PC at the moment is a TMS570. I've used the Halcogen in order to be able to create the initialization code for this device, and from this I've generated a library that I've linked then into the project where I want to test my assembler code. So here I have my assembler code, and inside here I've got two functions, safe string length and also safe string compare. And in order to be able to exercise this code, I've got a main here, and inside I'm actually going to be calling safe string length several times, and the same for safe string compare. And if the tests pass or they fail, I'm then going to print out the result. So let's go and check that this builds. So there we can see it's already built, so that's good. Now I'm going to go into my Explorer here, and I want to execute from a batch file. Now in this particular case it's going to connect to the target, so it's connecting to the XDS 110 USB debugger, and as we can see it's downloading to the target, it's executed, and I've got the results off the target, and most importantly the tests have passed, which means that my assembler code is doing what I expected it to do. So now let's do the same, but this time let's find out what assembler coverage we obtain. So to do that I'm going to go into the ARM7 assembler testbed, and I'm going to load a set. So I have a set here that contains that file, and so I'm now going to go and statically analyze it. Then I'm going to generate an instrument program to put probes into the assembler code. I'm going to build it, execute it, and then get the coverage. So let's start this. So here it's analyzing the code. It's now performed the build. We're now about to execute on the target. Okay, so this is connecting, and it's downloading the program. It's then going to execute it. We're going to capture what happens to a file, and there we can see we now have the same results as before. So we can see all the tests have passed, which means that our probes we put into the code, which we've captured here, have not actually affected the behavior of these functions. So now let's process this. So now it's going to extract those execution history information, and we're going to be able to take a look and find out, well, what coverage did we obtain? Well, as we can see here, we haven't got 100% statement or branch coverage. Let's go in and take a closer look. So we've had one run, and as we come down we do have 100% statement, 100% branch coverage for the safe string length. LCSJ is linear code sequence and jump. That's effectively looking at the paths through the code, and we've had 86% of the paths that have been covered. Well, let's take a look at the test where we haven't got the coverage or the function, and here we have the safe string compare, and as we can see we've had a branch if not equal, and we've never dropped through this, and so we've never executed these lines of code here. Similarly, we have more lines of code that we've not executed here. Alright, so that's looking good. Now what I want to do is I want to try and increase the coverage. So I've got some additional tests here that I've got commented out. So I'm going to include these, and hopefully this will give us much better coverage. So let's save this, and now let's execute this again. So once again I'm going to generate the instrument program, build it, execute it, and then perform the coverage. So that's now performed the build. It's now executing. Okay, so we can see it's downloading to the target, and it's going to start executing. We're going to capture everything to a file. Once again, we should be able to look at this file. We can see the execution history, and also we can see the tests have passed. So again, let's process that, and we should be able to find we have much better coverage. So once again, let's take a look at the test manager report, and this time we now have 100% coverage for the string compare. So there we have the string compare, and as we can see, we have 100% statement coverage, but we have a branch that's not been taken, and we can see here this is the branch that's not been executed. Well, we could see that in a slightly different way. Let's go to a flow graph. So this is a call graph showing the two functions, and if we were to take a look at safe string compare and open the flow graph, now I can switch this to show the annotations, and there we can see we have this branch that we've not taken. Basically we've got a branch if equal, and this has never been equal, so we never executed that branch. So hopefully that's given you an idea of how we're able to measure code coverage on assembler code. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.